Hello, good morning. Yesterday we started with linked lists and what is a node. Like I gave you an introduction about a node and how is it different from an array. Like arrays are static, that means the memory is allocated during compile time. So you cannot, it's like you cannot change it, whatever you have done, like you have allocated is allocated, so it cannot be reused by some other element also, because during runtime you cannot deallocate or desize the thing size of the array. You cannot resize it, because if I say 100 elements, you cannot change it to either 150 or 50. Like you cannot change the size of the array during the runtime. You can depend on number of elements in the array, that is different. But when I say I will have an array of 100 elements, depending on the data type, that many bytes of memory would be allocated to that. So you cannot reuse, that place is fixed, like you blocked. Actually you cannot use it for any other to store anything else apart from the elements of the array. So whether the number of elements in the array is different, whether I have one element or 10 element or all the 100 elements, it doesn't make a difference, right? Because once it is fixed, like that many bytes is allocated, wherein I cannot use it for anything else. The same way, it's like better, because many a times we may not know like how many bytes we would require, or how many elements we would be storing in a list. When the number of elements in a list is not fixed, and as and when it can either increase or decrease, like in a queue, for example, the queue is dynamic, right? It can increase or decrease, and there, so at one point of time it can be full, at one point of time there may be one or two elements. Like it is not fixed, such things. You If it is possible to allocate and deallocate that memory, that is, allocate when you need it, and when you don't need it, just deallocate that memory, or free, or put it back to the memory, so that free pool or heap, then if it can be used by some other element, it would be optimum, right? It would be maximum useful. So that is where you have linked list. Linked lists are nothing but wherein you can dynamically allocate memory to it, and then the data is stored. How is the data stored? The data is stored in the form of nodes. Here you can see here as a node, and in this, one is the information part, the other is the link part. Why is it? See, when I say an array, it is all continuous memory location. Like for example, an array of 5 elements I have, and I have 1 byte for each element. Like if it's a character array, it will need 1 byte for each element, and for my memory location starts from 100, so it would end at 105, because 1 byte for each, so it will be continuous memory locations stored therein. The data elements are stored one next to another, whereas in a list it is not like that. It is not continuous memory locations, it can be scattered in memory. Why is it? Because I create a node. Now, for example, my node, I am going to store some integer in that. So 2 bytes of memory would be allocated. For that 2 bytes, I would that node would be created. That many bytes would be allocated. Then, after some time, I want to insert one more element. Then I would create one more node. Yeah, data is stored in nodes only, wherein node has two parts. One is the information part, which contains the data of the node, or the information, or the data, whatever you can say. The other one is a link part, which is a pointer, which points to the next node in the list. So pointer is nothing but which stores the memory location. Correct? Why do I need it? Because now I may create, after some time I may create one more node. So it will not be continuous, like one next to another in memory. So I should know where is the next node, right? Like for example, the first one is created in 100, second one may be created in location 10,000 also. So there is like, it will be scattered wherever that many bytes is available at that point of time, that it will be created. So how will you link it? Because you need to traverse, right, one after the other. If you want to do the traversal, the sorting, insertion, deletion, you should know, like you should be able to traverse it. So what I do is, we have a link part which is a pointer which points to the which will hold the memory location of the next node in the list. That is why I have a link part here. Please go through this again, because yesterday many of them had a lot of confusions, so I'm just telling this again so that you will understand. I won't be repeating the class again, only just what it is. So they are logically linked to one another. They are not physically next to one another. That is, they are not stored in continuous memory locations. They are scattered in memory, but then the link part holds the memory address of the next node, so that from with the help of the link part you can access the next node and traverse it. Getting it? That is a linked list. And then if I want to delete a node in the list, and then I can do it dynamically, as I can allocate memory dynamically. When I say dynamic memory allocation, during runtime, that is when you are executing the program, during that time, depending on if you want to insert data, you go on creating nodes, and if memory is available, that many nodes would be created. Once I want to delete a node, if I delete an element from the array, the element will get deleted, but that is, you can take out the element from the array. Yeah, I can delete an element from the array. We have done array deletion, but then that memory will not be put back for reuse, right? So here what happens is, you can deallocate that memory, or you can free that memory, and it can be reused again. That is allocation and deallocation of memory during runtime, when the program is executing, and they are done with the help of new and delete operators. So new and delete is here. 1 minute. Yeah, this is new and delete. New is an operator which allocates memory during runtime, and delete is used to deallocate that memory or free that memory during runtime. So what is the syntax and all? It is here. Int star temp tmp temp is a pointer of type integer. That is, it is going to point to a location wherein the integer data is stored. Then temp is equal to new is a keyword over here, to which you are passing the data type. It takes the data type, and then suppose if you want more than, like if I say new int, it will only give 2 bytes of memory. So if I say new int of 5, it will be for 5 into 2, that is 10 bytes of memory would be allocated. It is just new int will give you 2 bytes, because it is for one integer. Here I am saying I will have 5 elements, that is why for 1 is 2, then for 5 it is 10. That many bytes of memory would be allocated, and it would be, temp would be pointing to that. This is how with during runtime, when I do programs, we will do it again. So this is just, I'm telling you what it is. And then delete is to deallocate. Delete temp would t tmp delete temp, instead of pointer over there, if I give the name of the pointer, it frees that memory, like it deletes that, and so that puts back into free space, that is free pool, or I can say puts back into heap, wherein it can be reused again. This is just the concept of linked list. Linked list is nothing but the data is stored in the form of nodes, and nodes can be created or deleted during runtime. I can create a node means I can dynamically allocate a memory for a node, and then I have to just see, once I create a node, I need to attach it to the list, right? Otherwise you will not be having traversal. So that is one operation, and then the node will have two parts. One is the information part, which contains the data of the node, that is whatever, suppose like I told you, the receipt number I need to store. So the receipt number is the data, and then it will have a link part which will have a pointer which would point to the next node in the list. And then what are the operations I can do on a linked list? How do I create the different operations are creating a linked list? Yes, I need to create a list traversing a linked list. When I say creation, it is list creation. To begin with, there are no nodes. Elements of the list are nodes only, wherein the data and the information and the link part would be there. Once creating a list is nothing but you create a new list and then you will see whether that is the first node in the list or not. If it is the first node, and then here I will have a pointer called head which will always point to the first node in the list, otherwise it will be null. I will write it and show it to you, you can listen to me. Otherwise it will be null. Head would be the, I would be using it as head. Some books they would have given start, whatever. Like, see, that is the first star would be pointing to the first node in the list. It is also of the type node only, which will point to the first node in the list. And then if there are no elements in the list, it would be null. Otherwise, once you first create the first node, you will check whether the head or the start is null. If it is null, make it point to the new node. And link part, anyway, when you create a new node or creating new node is nothing but dynamically allocating memory. That time first you ask the user to enter the information part, store it in the information part. And how do I store it? Because in the information part you do have declared, yesterday's class I showed you how to declare a structure. That in today's class also I will tell you. So you would have declared a structure, information part I would have declared a variable. So 1 minute. I think I would have, yeah, here. See, this is a node and struct because it is a structure int info. So this is the variable which is going to hold integer value. So I can say float, ELE, whatever type of data you want to store, you can store there. Int info, here in this node linked list, I'm going to store integer data and the variable that holds it is info. So ask the user to enter the info and see that one you will take, since it's a pointer, node arrow info you would use for taking in because it's a pointer, or node star node dot if you are using it. We'll use arrow so because it's more simpler, and then struct node star link. So this link part you need to make it as whenever you create a node, ask the user to enter the information part, take into the information part, and then make the link part to null. That is the first step when you create a node. Okay, and this is the structure of the node. You can decide the structure of the node, like what would be the information part, like what type of data you would be wanting to have in the information part, and link part would always point to the next node. There would be no change in that, but then the information part you can have whatever type of data you want to have. That is, you need to declare it. I have declared it as int. You can have float, long, double, char, whatever you want to have there. After that, after taking it and writing in the information part and then making the link part to null, then you need to check whether it was the first node in the list or not. If it is the first node, how? Because head is null, it is the first node, make head point to this over. Otherwise, if it is not the first node, here if I have to attach it to the list, I need to traverse the list, go to the last node, make the last node point to this node, right? If I am attaching it in the end. So that is just the generic syntax. I will show you how to do it. I'll write the node and I will show you. I'll try to explain, then we will write the algorithm also for that. Before that, we will just go through what are the operations performed on list. Creating a list, yes. Traversing a list, yeah. Inserting, traversing is nothing but visiting each element of the list at least once, and then deleting an element, searching and merging. We did traversing. So this was the algorithm yesterday. An algorithm traverses the linked list. Here, start contains the address of the first node. That is what I said. The head start, you need to specify what is the address of the first node. That's all. It's a pointer which points to the node of the type node only, which would be pointing it to the first node, because you need a point where from where the first node is starting, the starting point of the list. So I will have either star or start or head or first pointer, whatever you want to name, you can name it. So algorithm traverses start contains the address of the first node. Another pointer P. Why do I need it? To traverse, because I need to find. For traversal till the end of the list, I need to travel. For that reason, I can use either current pointer or P, whatever you need to name. Then that is also should be of the type node, because it would be pointing to the structure node. So another point P is temporarily used to visit all the nodes. Start, P is equal to start. Start is pointing to the first node, so P also now is pointing to the first node. So P is equal to start, two pointers. When the pointers are same, I don't need ampersand, I can directly assign it. That we did in pointers chapter. While P is not equal to null. When will be P null? I told you also the starting of the list is identified by head or the start pointing to the first node, and the link part of the last node would be pointing to null. So until P, link of P is not equal to null, you are going to traverse, that is link of P. P is equal to link of P. Link of P would be pointing to the next node. So like that you go on traversing it, and whatever you want to do, whether you want to count, compare, check, search, whatever or sort, whatever you want to do, you can do it, and then you stop it. Or you want to print it also, start from the first node and go on. See, with cout statement you are able to print the information part also. So this one I will again show you how does the traversal work. See, yeah, suppose first pointer is nothing but start. If I take that, and P also is pointing, it is pointing to the first node. Okay, so link part P is link of P. Where is it pointing to? Link of P is pointing to the next node. So P is equal to link of P. It will go here like that only. P is equal to link of P. Like that you go on, because link of P would be pointing to the next node. Like this you go on pointing until you reach the last node. When the link of P is null, you stop. That is what traversal means. I want you to write this algorithm. Yesterday, many of them had requested for little more time, so I'm giving you a minute's time to write it down. Hopefully, you've written it and understood. At least, if you're able to understand half, that is fine, because by the end of the chapter, you would 100% understand how once we start doing it, because linked lists are little difficult when compared to others. So, hopefully, I've written this. Traversal operation is done. Next is inserting a node. So, inserting a node is allowed at the beginning, at a given position, or at the end of the list. It does not follow LIFO or FIFO. Okay, so I can insert a node at the beginning of the list. That means that I already have a linked list. So you want to add an element into the list, and then it has to be in the beginning. That is, you want to make it as the first node in the list. So what you have to do, you have to make head point to this and then this point to the node to which head is pointing, right? So inserting a node at the beginning of the list, inserting a node at a given position. Like for example, I have 10 nodes and I have created a new node and I need to make it as a fifth node. So at a given position, anywhere in between, not in the beginning, not in the end. If you want to insert a node anywhere in between, inserting a node at a given position, then inserting a node at the end of the list. That is very easy, like inserting a node at the end of the list. Beginning is also easy, end also easy, but then at a given position is little complicated, right? Because given position, you take care of two nodes. That is, the previous node has to point to the new node and this has to point to the next node. Whereas here the beginning or the end is very easy when compared to at a given location. But we can insert a node as the first node in an already existing list. So you already have a list and you have created a new node and then you want to make it as the first node or the last node, that is in the end, and a given location is anywhere in between. All the three can be done. So inserting a node at the front, like what I have to do here, I have a pointer and here I am telling it as first pointer, or I can say head. Inserting a node at the beginning of the list, what I need to do, first I have created a new node. See here, I am creating a new node here which is not there in the list. The A list has two nodes. One node has got 7 stored in the information part. The other node has got 11 stored in the information part. So the list A has two nodes, 7, and that is, node 1 has 7 in the information part and node 2 has 11 in the information part, and this dash means it is pointing to null. So the link part of the last node points to null, and first pointer is a pointer which points to the first node in the list. So the node to which the first pointer is pointing to, it need not be first pointer, it can be start also or it can be head also. Whatever name you want to give, you can give. So that is pointing to the first node. Now I have created one new node here. It is not at all linked here anywhere. Getting it? It is a new node. I have dynamically allocated memory to it and I have a pointer called new PTR which is pointing to that node, and I have stored 12 in the information part, and the link part I have made it point to null. Now whatever new node I have connected, I need to make it as a part of the list A and I want to make it as the first node. So which is the first node here? This one is the first node. I want to make this as the first node. This will become second and this will become third. Fine. How do I do that? Create a node, fill the data. Yes, I created a node here. I will fill the data field in the new node. That is, data field is 12 is filled. Mark its pointer field as null. Yes, I have marked the pointer field as null. Attach this newly created node to the start. Start is nothing but the first pointer, and make the new node as the start. See, it needs to point here and this one should point to this. Then it will get attached. So how do I do that? We will see. Before that, I will do this one in the end is first easy. We will do in the end and then I will show you how to do it in the beginning. Getting it? So we'll start with how to do it in the end. See, whenever I create this, I will get, suppose this is a node. This is how a node looks, information part and a link part. And to begin with, it will point to null. Okay, I will create a new node. I will store the information in the new node. How will you store that? Ask the user. Like before that, how will be the new node? Let me write the code for it. How will be the new node? Before that, I need to have the structure. So I will say struct, okay, node. Let me name it as node. And since it is a structure, let me open this. And since I can see integers here in my information part, I will say int element or info, whatever you want to say. Okay. And then I have struct node star link. Okay. And then I will say struct node head, star head, star head, comma, star. Okay. So I have two pointers which would point to a node. So this is how I created. Like struct is the keyword, node is the name of the structure, and in that I have integer ELE. In the information part, I am going to store an integer, and then struct node star link. Like star link, link is a pointer which is going to point to a structure, like it will point to a structure node, right? This one is pointing to the other node, the same. And then I am creating two more pointers called the head and the current pointer, which would point to the node. So which would point to a node. This is the way how I will create. Please pay attention. Linked lists are not very easy. It is little complicated, but then you can understand it. So struct node, first you have to say what will be my node like what will I have in my information or the data part. Link part, yes, it will always point to a node, that is done, you don't have to change that. But then information part can be an array of a name, or it can be a float value, a double value, or int value. So here I am storing integer. I will say struct node star no, sorry, int ELE. So whenever I am asking the user enter the information part, I should take it with C in ELE only, right? Because I have declared it as ELE. ELE is the variable which is going to hold the info data in the information part of the node. You can give it as X, Y, Z, any variable name is allowed. So int ELE, I have given the name ELE, and then I have the link part. So these are the two elements in my structure node. This is how my node will be. It will have a link part which will point to the next node of the same type. That is why your name also should be same, struct node. That is node, because there may be many structures, right? So I would be pointing to a structure of type node. That is why it was called self-addressing pointer. It was pointing to a same structure or the same type of structure, right? So struct node star link. So star link would be pointing to the next node of the type structure node. And then these two are also the pointers which would be pointing to node, structure node. Or if I take out this keyword struct also, node star head star current pointer also will work. Then so this one I created. So that time I know node, I'm not creating a node here. Getting it? I'm not allocating memory here. I'm just saying that my node structure is like this, that it will have an integer in the information part. In the link part, it will have a pointer which will point to a structure of this type, that is of the type node. Yeah. And also I will have two more pointers which will point to the same thing. After that, how will I allocate memory dynamically during runtime? How do I allocate memory during runtime? What is the this one used? The code First I need to create a pointer, then that pointer is equal to new of data type. That is the thing, right? How, suppose if I want to allocate for an integer, this is example. If I want to allocate for an integer pointer, I will say int star ptr. Okay, then I will say, this is an example. The same way I'm telling you, I will allocate for this node also. Getting it? Then I will say ptr is equal to, this is not capital, this is lowercase only because I've declared it in lowercase, is equal to new int. This is how you dynamically allocate memory. Getting it? So int star ptr. Int is the data type, star ptr is the pointer. So if I want to dynamically allocate, that is allocate memory to ptr during runtime, this is how I do it. Ptr is equal to new of int. Getting it? New int is how I will be doing it. Now, if I have to dynamically allocate memory to a node, like how do I create a node during runtime? This is only a part of the code I am telling you. When we write the algorithm, I will write create a new node. But when you actually write the program, you have to write the code for creating a new node. What is the code in for creating a new node? That is what I'm telling you, how to take in the information part and how to make the link point to null and how to dynamically allocate memory. So first you have to say, I will say struct, or I can directly say node also, fine. Node and star, give a space, star new node. So here what I am doing, int star ptr, same way node is a structure. So the data type of it is structure. You can say struct node star new node. So new node is a pointer which would point to the structure node, right? Then I have to allocate memory. So here what did I do? Here I will write new node. That is equal to, new is the keyword, and then I need to pass the data type to it. So I will pass node to it. So whatever is the size of that structure, that many bytes. Here the data type, how much bytes will be allocated? 2 bytes. If suppose the structure here has a character, it will be 1 byte. If it's a character array, suppose 30 characters, that many bytes would be allocated depending on the data type. So this is how you dynamically allocate memory. First you create the structure. You say that okay, the structure will have an integer value. ELE is the element or the variable which will take the integer or the data part of the node, and link I have, which is star link, is a pointer which would be pointing to a struct node, that is to pointing to a node. Getting it? And then this is an example how to use new, that is during runtime, how do you allocate memory? First declare a pointer of that type, that pointer is equal to new is the keyword, and then pass the data type as the argument. Here also I am doing new, and star new node is a pointer. New node is equal to new is the keyword for dynamically allocating memory. Don't get confused between this and this of node. So that many bytes of memory would be allocated to new node. After that, I want to ask the user to enter the information part. How will I write it? Cout enter enter the information part. Okay. So how will I take in C in? Now I have to access the structure, right? So new node, with the help of that, yeah, then I have to use arrow because it is a pointer. If it was a not a pointer, you use a dot. Since new node is a pointer, I will use a arrow. So new node, and then what is the variable? ELE. Getting it? This is how I make, and then I need to make the link of new node to null. So how will I do that? So this is the link. New node's link is equal to, this is how I can assign or set. Getting it? This is like I will do it as a program and I will tell you the logic also, but then this is just a brief idea to you, like how I can create a new node and how do I allocate memory dynamically. In algorithm, you don't need exactly using new and delete. You just write create a new node and then take in the information part and make the link part null. But when you actually code it, this is how you do it. Please have a look. So, see, don't get confused or like this thing. Just many people were yesterday curious to know how exactly will I make it null and how exactly I will create it during runtime. So, I will put this code in a function like create function. Whenever you want to add a new element, I will call the create function. In the create function, I will have this code like dynamically creating. Before that, I will write this structure as a part of a class. Okay, because a structure is also a data type, you can have it as a part of the class and all this declaration part. And then whenever I want to create a new node or I want to insert an element, I will write this code in the in the create function. And then what I will do, what I have done here, I have created a new, and with a new I have dynamically allocated memory, and then which that allocated memory new node, this pointer would be pointing to that. So after that, I'm just saying the user enter the information part. And what was the variable I declared in the information part? ELE. Since this is a pointer, normally how will you say new node dot ELE, right? For a normal structure, here I will say new node arrow because that is a pointer. That's all. ELE, and then I have to assign the link part to null. So null has to be in capital only. I will say new node link of this thing is equal to null. This is like I created a new node. It is not attached to the list or anything, because many of you were curious like how exactly I will create. So every time I want to add a new element, I will call this function, and then still this function will have like attaching, whether it is the first node or you have to traverse where you want to attach. That thing we will do in detail when we go there. But just I wanted to show you how I can create a node dynamically and take in the information part and make the link part to null. And again I will be doing it, so don't worry like if you are not able to understand completely. Yes, but then at least you will have one idea like how exactly I am doing it. Fine. Now we'll go back to the beginning. So this is my node. My node will have information part, link part, and then new node. So I also had the head is equal to null because head is the first node. If there is no node, I will make it as null. Fine. And then after creating it, I will add the information part here. Suppose if I say information part is 256, I have entered because I said int ELE. So integer, any integer. So this will go here, and then link is here, which will point to null. This is how my node will look after inserting. Then to create a list, first node, this is my first node. So what you will do, I will say head is equal to null, because I am telling you head is a pointer which points to the first node. According to my example, head is a pointer which would be pointing to the first node. So head will point here because this is the first node. Getting it? How will I do that? Head is equal to new node. That is a thing. So new node is this. Head is equal to new node. So head will also point here. Information part is there. The link part is null. Correct? And the last node will have the link pointing to null. Since this is the only node, this is the first node also, this is the last node also. Yeah? After that, what I have to do? Suppose I want to add one more node. Like I want to add one more element to the list. After some time, insert data into the information part and make the link part to null, and if head is null, it is the first node, so make head point to new node. Head will point to the first node in the list. In that example, they had given new pointer or start. You can give whatever name you want. The way I created it, I have created it as head, so you should have one pointer which points to the first node only, and it will not change its location. Always it will be pointing to the first node, so that you will know what is the beginning of the list, which node is the beginning of the list, and anyway the last node, the information the link part would be pointing to null, so you know which is the last node in the list. And I'm talking about single link list here. Getting it? Not even single circular list. I'm talking about the single link list. So then I created it. I stored 256 here, and then I link to null, and then what did I do? I checked. See, head is null here in the top. So head is null. This node I created, I stored. Then insert everything, and if head is equal to null, it means that it is the first node. So what I have to make? Make head point to null. Make head point to new node. So I am making head point here. Hopefully you've understood this. After that, suppose I want to insert one more node, and this is insertion in the end. Like after this I want to insert, not before this. So it will be end only, right? Because the end of the list, this is the only node. That is why beginning end is the same node. After this I want to insert one more node. What I will do? First I have to create a new node. I created it. I put the information part. See, it is not linked to anywhere. It's just independent. Once I create that code now with that new, it will just give me a node. Attaching it is later. It is not a part of the list when I create. It is an independent node. I inserted the information part, and then I have to make the link part null. That is the first thing what you have to do whenever you want to create a node. First you create a node, and then ask the user to enter the information part and make the link part null. After that you will see whether you want to attach it to the beginning, or you want to make it as the that is the first node in the list, or the end of the list, or at the given location. First, creation, entry of the data in the information part, making the link part null. That I did. Yeah, I have created. How did you create a new node? First, that create function I told you, no, you have to call, wherein it will create new node and then make new node is equal to new off node, that for dynamically allocating memory. Then ask the user, enter the information part, see in new node of arrow ELE, and then new node arrow link is equal to none. That is the code what I will be doing after that. How do I insert data into the information part and make the link part? Sorry, this is not okay. Make the link point to null, point null. After that, if head is null, it is the first node. But anyway, is head null? No, because I have already created one node and head is pointing to that. So head is not null, correct? Since this is a second node, head is not null. So if no, then it is not the first node. Yes, it is not the first node because head is not null. So I will create one more pointer of type node which will point to the node. That is called the current pointer. Current pointer is equal to head. So when I say current pointer is equal to head, what happens? It will create one more pointer of the type struct node and it will make point to this one because current pointer also, head is pointing here. So current pointer is also pointing here. See, this is not the node I am creating. 256. Data 256 is which one? This node. The first node which was already there. Not the new node where I entered 165. That is not yet connected to this. So what I did? Since this is not the first node, I made current pointer. That is also another two pointers I created, head and current pointer, right? So I made current pointer also point to head. So this statement will make current head is equal to current pointer is equal to head, means it will also point to this node. So 256 let null. So two pointers are pointing to the first node. Now the other node is not yet connected to this because this null, instead of null, this link part should point here, right? This link part should point here and this null is correct only because the link part of the last node is null. After that, what I will do, while current pointer, link of the current pointer is not null. Link of the current pointer is not null here because it is pointing here, right? To a node it is pointing, so it is not null. Current point, it will go inside the while current pointer is equal to link of current pointer. So current pointer is equal to link of current pointer. What is link of current pointer pointing here? It is pointing to null. So what will it be now? It is null. Next time when it goes here, it will give me error. It will not go inside this thing because now current pointer, instead of pointing here, it is pointing here. Correct? Now link of current pointer is equal to new node. So this one will point to this. Link of the current pointer is equal to new node. It is pointing here, it got attached and null as it is. Getting it? Now one more new node I want to attach. So I have, what did I do? Create a new node and insert the information part in the link part. Now I want to attach this one as the third node here. So create a new node. I did that and I checked whether the new node is check if new node is the first node. No, it is not the first node. So if head is equal to null, no, head is not null because there are already two nodes in the list. So no, current pointer is equal to head. So current pointer would be pointing here. After that, what will I do? After that, I need to say the same code will go there. While link of current pointer is not equal to null, current pointer is equal to link of current pointer. So here current pointer is not equal to null, then current pointer is equal to link of current pointer. What it will do? It will point here. Again it will go back, then current pointer is equal to link of current pointer. It will point here and then here again when I say current pointer is equal to link of current pointer, it is null here. So then you go out there and then what are you doing here? What are you doing here? I say link of current pointer is equal to new node. So this one will, instead of pointing to null, will point to the new node. So how will it point? One minute. So instead of null, it will point to the new node. Okay, instead of null, it will point to the new node, and then this is null. This is how it will work. We will do this again. I will repeat it again. Hopefully some, at least 50%, if you are able to understand also, that is fine. We can do that again. It is not a problem. So homework for today. The first question, list the different operations possible on a linked list. List the different possible on a and the second one is list the different types of or variations or types of linked list. List the different variation or I can say types of so we'll just go through a short recap here. What am I doing here is, the thing is, you first create a node, then take in the information, create a node, then take in the dynamically. During runtime, take in the information part, make the link part null. After that, I have two pointers. One is current pointer, one is head. First, during creation, after that in the constructor, I would have initialized head is equal to null, because there are no nodes in the list. In an empty list, it will be null. After that, after creating the first node, what I will check is whether this is the first node or not. How will I know? If head is equal to null, it means that it is the first node. So what I do, head is equal to new node. So head will point here and the link part will point to null here. This is done. Next, when I create the second node, that time I need to attach it here. So what I'll do, first I'll make the current pointer. First I'll create the node, take in the information part, make the link part null. Then I have to attach it to the list. So how do I do that? I will check whether head is null. If head is not null, it means that there are nodes in the list. And if I want to attach it, in the end, I have to traverse the list. So starting from head, with the help of current pointer, I will move until the link of current pointer becomes null, because the link of current pointer will be null only when only during the last node in the list. So I will say while link of current pointer is not null, current pointer is equal to link of current pointer when it enters the list. Head is pointing here, current pointer is also pointing here. So the link of the current pointer is not null here, right? Because it is pointing to this node. And then here in the while I am making current pointer is equal to link of current pointer. The link of current pointer is pointing to null. So it becomes, because here on the top it was pointing to null, right? The link of current pointer is pointing to null. Then it will go out for the next iteration. Link of current pointer is equal to new node. So link of current pointer will point to the new node, and anyway the link is pointing to null, so you don't have to worry about that. The same way, third time what I will do, link of current pointer will point here, again the link of current pointer will point here. So hopefully you have understood at least 50%. Tomorrow's class we will do it in detail. Again I will repeat it, so you don't have to worry about that. Take care, stay safe. See you tomorrow. Bye bye.